Hey, welcome back to Well, That's Interesting, the best way to celebrate all this vanishing history edition. Today is a bonus, the weird chemistry threatening priceless paintings. My friends, if you're currently on the landmass known today as the United States at the time this is airing, then you know it's currently a particular holiday. And that images, statistics, biographies, chapters, paragraphs, entire studies, objects, and even people are disappearing from institutions designed to make sure we never forget. So, in honor of all of this whitewashing, I think I nailed it in a fun way. Today, I'm going to share a spectacular video over at the Tube of You called, you guessed it, The Weird Chemistry Threatening Priceless Paintings. It's written and hosted by Sarah Everts from Reactions, a channel whose goal is to, quote, break things down to the molecular level to show you the chemical reactions that shape our world. And we won't stop until we're satisfied. Or someone almost sets their basement on fire. End quote. Well, there won't be any fire destroying anything right now, but I chose a video that highlights a completely different reaction. One that's causing havoc throughout the art world. Back when we were but a twinkle in our mother's eye in 1996, art conservator Petrea Noble was doing what all conservators do at some point in their careers. Find themselves in front of a 400-year-old Rembrandt and mumbling, "Christ, not this guy again." I mean, I could only assume she said that because Rembrandt's paintings are slowly transforming into pockmarked problems. And it's not only Rembrandt's. Craters that could be seen with the naked eye are showing up in Van Goghs, Mondrian's, O'Keeffe's, and others that haven't been hidden away by certain regimes. Anyway, as we will hear, Petrea went on a quest to find out what is causing these supposed holes and what the substance is that's coming out of them. You heard me. And as you're about to hear, the answer is incredibly surprising. You can fire up the old tube and search The Weird Chemistry Threatening Priceless Paintings to watch along, but I'll also have some screenshots over at our socials for the highlights, including a close-up of a cross-section of the substance leaving conservators stumped. So here we go, with slowly destroying classic works of art.
When art conservator Petrea Noble was preparing to clean a nearly 400-year-old Rembrandt, she noticed its surface was riddled with microscopic pockmarks. And Petrea is not alone. Other conservators have reported this strange phenomenon on thousands of other oil paintings. In addition to threatening the splendor of these priceless pieces of art, the blemishes are driving some in the art world crazy. But researchers finally know what's creating the strange craters. Petrea first noticed the pockmarks under the microscope in 1996. As it turns out, decades before she came on the scene, other museum researchers had also seen the craters. Her predecessors speculated that tiny gas bubbles had percolated out of the painting, leaving pockmarks behind. Petrea wanted to understand the anatomy of the pockmarks, which, by the way, is awesome because it's meta. The painting is called Anatomy Lesson of Dr. Nicolaus Tulp. Anyway, she carefully removed tiny cross-sections from several craters. It turns out that many of the craters contained a white muck that kind of looks like insect eggs, but these white lumps are neither insect eggs nor gas bubbles. Petrea and her collaborators figured out that the strange white muck is actually lead soap. Yeah, soap, like the soap Rembrandt might have used to wash his hands after a long day of painting. Only instead of being produced by 16th century cosmetic makers, this lead soap is a product of the painting itself. And don't worry, your bar of soap at home doesn't have lead in it. It contains sodium or potassium instead. The lead soap formed over many years within the artwork when lone fatty acids from the oil paint encountered meandering lead ions from pigments. And metal soaps are often bad news. When they form at or near a painting surface, they can burst through, leaving pockmarks that make the art look hazy, gritty, and dull. The soaps can also leave disfiguring crusts and reflective films on the painting. But the problems get worse if enough metal soaps form deep within a painting. The slippery soap can cause something called delamination. That's when layers of paint deform, lift up, and flake off. Not something you want in a piece of artwork whose value is measured in millions of dollars per square meter. Understanding what's going on in these masterpieces has required that scientists literally watch paint dry. And here's what they found. The oil in oil paint usually comes from linseed plants, also known as flaxseed. Linseed oil features a glycerol backbone, which can support a variety of fatty acids such as linoleic acid. When exposed to air, the fatty acids polymerize into a complicated mesh that becomes the tough material you may know as dry paint. Besides oil, every paint also contains its own peculiar mixture of colorful pigments and additives that, for example, help maintain the paint's texture and stability. But it turns out that the incredibly complicated chemical system we call dry paint is not always stable. Over time, heat and humidity sever the fatty acids from the paint's glycerol backbone. These negatively charged fatty acids wander through the paint's polymer matrix until they're drawn to positively charged metal ions like lead and zinc, which are used in pigments. The fatty acids and metals marry to form soap, which accumulate into white lumps. Conservators around the world have discovered soaps in artwork by Francisco de Goya, Vincent van Gogh, Piet Mondrian, Georgia O'Keeffe, and many others. Artwork from the 13th century all the way to modern day. Although we understand the basic chemistry behind metal soaps, conservators are still trying to figure out the best ways to clean these soap-laden paintings, and whether cleaning is even a good idea. That's because one of the safest cleaning strategies available to conservators, namely using good old water, may actually accelerate metal soap formation. So what do you think? Is it worth the risk to try and clean these works of art? Or should we just learn to appreciate the haze from metal soaps like we do the green patina of oxidized copper? Tell us what you think in the comments.
Well, there you have it. To clean or not to clean, that is the question. I personally would love to see what kind of an abstract deformity a Rembrandt turns into after being left alone. But you could ask your friends, or especially your family, what they would do. Because on a day like today, a question like this will certainly help. You could avoid one kind of argument with another. Oh, and by the way, I looked a little farther into metallic soaps, which, like our concerned lady Sarah here noted, form when rogue negatively charged fatty acids find themselves attracted to positively charged metal ions. We've all been there. Under the umbrella of metallic soaps, there's a subcategory called alkali or alkaline earth soaps that provide a variety of uses. Soaps like magnesium stearate and calcium stearate are used as lubricants and, you guessed it, food additives. For example, the U.S. candy called Smarties contains calcium stearate, and these food additives are identified by E numbers like E470B and E470, respectively. So, enjoy dinner. Enjoy dessert. I am especially thankful for you and the entire flock. Thank you for listening, rating, subscribing, doing all these tiny things to make the podcast grow. That makes the flock grow. You are incredible. And a stuffed thanks over to the folks at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you'll love the other podcasts in this family. And please, stay interesting.